Now system of linear inequalities, that is I don't have one but I have multiple linear inequalities for the same variable. Like let's say 2x plus 4 is greater than or equals to 6 and x minus 5 is less than or equals to minus x minus 5 is less than or equals to 3. So I need to solve them individually and get the zones, right? And then I need to pick the common zone in between, because that values of x should satisfy both, not just one of them, right? So I need to pick certain values. So let's say certain values like 1 and 3, between 1 and 3 is satisfying this inequality, and this is satisfying 2 to x is between 5. X will be between 2 to 5 and this is x is between 1 to 3 to satisfy. When will I satisfy both the equations? When x is between 2 to 3. Because x can be between 2 to 3 here, x can be between 2 to 3 here. X can be between 1.1 to 2 here, like x can be 1.5 to satisfy this, but x says 1.5 won't satisfy this because x has to be between 2 to 5. X can be 4.5 here, so that it is between 2 to 5 and satisfies this inequality, but it won't satisfy this because 4.5 is not between 1 to 3. Right, so I need to pick the common area, that is x between 2 to 3. So anything between 2 to 3 is here and as well as here. That's why the answer would be this for that. I don't know, I'm just giving an example. Okay, let me solve these inequalities to find the actual zones. So 2x plus 4 is greater than or equals to 6. So 2x is greater than or equals to 6 minus 4 is 2. So x should be greater than or equals to 1. So what is the zone for this? X should be greater than 1. So everything here is accepted for me. Right? 1 to infinite, x belongs to 1 to infinite from the first inequality. What about the next one? Minus x minus 5 is less than or equals to 3. There are two ways to do this. One way is this, like how we normally change everything, right? So send this to this side. So minus x goes there, it becomes x positive. Minus 5, 3 comes here, plus 3 becomes minus 3. So that is basically minus 8 is less than or equals to x, or x is greater than or equals to minus 8. Other way to look at is this, multiply this entire inequality with minus 1. So minus 1 into minus x is plus x, minus 5 is plus 5, 3 into minus 1 is minus 3. You need to swap this sign. So it's less than or equals to becomes greater than or equals to. Just don't multiply with minus 1 and keep this as it is. That's the mistake that I see some of the students doing. If you are multiplying everything with minus 1, in the case of inequality, the sign should change. So this will come as x plus 5 is greater than or equals to minus 3. 5 goes this side. X is greater than minus 3 minus 5 greater than minus 8. It's the same thing, right? As I said. So what does this mean? X belongs to minus 8 to infinite. So as long as x is between minus 8 to infinite, I will satisfy this inequality. As long as x is between 1 to infinity, I will satisfy this inequality. So what should be the answer? If I look at the common areas between both of them. So this one looks like this, right? Minus infinite to infinite and minus 8 comes here, let's say. This is all accepted. And where would 1 come? 1 would come somewhere here. So 1 to infinity is accepted for the first one. Whereas for the second one, minus 8 to infinity includes 1 to infinite. So the answer is 1 to infinite. If x is between 1 to infinite, that satisfies this inequality and also this inequality. Because for second inequality, if x is minus 8 to infinite, everything is fine for it. So 1 to infinite is also part of it. So the answer is 1 to infinite. That's how you solve a system of linear inequalities. Solve the following system of inequalities. So I have 3 inequalities. So let me solve the first one. 4x minus 2 is less than 6x plus 2. So let me send this side and this side. 4x becomes minus 4x. So 6x minus 4x is 2x. Minus 2 and minus 2 is minus 4. So x is greater than, 2x is greater than minus 4, x is greater than minus 2. So this is basically minus 2 to infinite. This is my first inequality. What about second? 2x minus 5 is greater than minus 3x plus 10. Minus 3x becomes plus 3x. Minus 5 becomes plus 5. 5x is greater than or equals to 15. X is greater than or equals to 3. So x belongs to 3 to infinite with a square bracket. 3 is also accepted. The last one is x minus 4 is greater than minus 2. This goes this side. X is greater than 4 minus 2. So x is greater than 2. So that means x belongs to 2 to infinite. So if I see it as a number line, the first inequality is satisfied as long as x is between minus 2 to infinite, right? What about the second inequality? Let me use a different color. It's 3. 3 is also accepted. 3 to infinity is accepted. What about the, one second. Yeah. What about this one? 2 to infinite with not including 2, but okay, that will be this zone, right? So what is the common area? This one, right? See this, I see red, green and blue. If it is coming out difficult for you to visualize, at least understand from this. So the purple is this zone from -2 to infinite. The red is from 3 to infinite and green is from 2 to infinite. What is the common area which has all three colors? This color, right? 3 to infinite. So the answer is 3 to infinite, which would satisfy all three inequalities.